We're going to look at energy level diagrams. So the Pauli exclusion principle, where only two electrons of opposite spin can occupy an orbital, is what we learned in our previous lesson. We're going to add on to it here. The following diagram shows the total number of orbitals in which electrons are likely to be found for all naturally occurring atoms. We're not working with ions yet. The orbitals are listed in order of increasing energy. We can see the energy is increasing as we go up. The further away from the nucleus is the higher the potential energy. So before we do an example, I just want to read a couple of rules. We have a Aufbau principle. Place electrons into orbitals in order of increasing energy level. So here we drew this with increasing energy levels, but an easy way to remember this is if we draw kind of going upwards as such in that diagram. I like to do it as a continuous line like this, where we're going to continue going up and up and up and up. This tells me what order I fill my energy levels with electrons, etc. Each set of orbitals of the same energy level must be completely filled before proceeding to the next one. So if I have 3 electrons, I need to fill 2 at 1s and then 1 at 2s. I can't just put 1 in 1s and put the remaining 2 in 2s. It doesn't work. So what that means is if I have 3 electrons, I need to put 1 here and another 1 here. This indicates one spin one way, and this represents the opposite way. So these are my 2 electrons. I need to put them here together and then put 1 here instead of doing just 1 before my next one. This is not allowed. Okay, Hund's rule states that whenever electrons are added to orbitals of the same energy sublevel, each orbital receives 1 electron before pairing occurs. When electrons are added singly to separate orbitals of the same energy, electrons must all have the same spin. All right, let's put it into action. So let's look at chlorine, for example. We know, I'm going to make this a little bit smaller. Chlorine has 17 protons, 18 neutrons. The first energy level has 2 electrons. The second energy level will be full at 10. And then our last energy level will have 7 to give us 17 electrons. Okay. We are going to start to fill our energy level diagram for chlorine. The first 2 electrons that I have here are going to go in 1s. So I go 1, 2 with the opposite spin. Now I've subtracted 2 electrons in my 1s orbital, and I have 15 electrons left to give for my energy diagram. My next energy level is 2s. I'm going to fill it completely with 2 electrons. That's the maximum that it can fit. One that's spinning positively and one that's spinning negatively. I've used 2 electrons. I now have 13 electrons. This was from my 2s orbital. In 2p, I have space for 6 electrons. So I'm going to go 1, 2, 3, 4, 5, 6. When I subtract 6 electrons in my 2p orbital, I have 7 electrons left to give. Following Aufbau's principle, from 2p I go to 3s. I have 2 electrons here, 1, 2. This is my 3s orbital that I'm subtracting. Now I have 5 electrons. Remember that the 3p can hold 6 electrons, but I only have 5 specific to chlorine. So I'm going to have 1, 2, 3, filling up all of the orbitals first based on Hund's rule, which states that 1 electron in each orbital before we double it up. So we have the 3, 4, 5. This tells me about the electron configuration, or the way that electrons are in the atom of chlorine. So we're going to write an electron configuration here. In my 1s energy level, I have 2 electrons. The 1 represents our n value, and this 2 here represents the number of electrons that it holds. Next, I have 2s2, I have 2p6, 3s2, and 3p5. This is my electron configuration for chlorine. We'll do a lot more examples with these.